let's have a look at these problems. Okay, first one, you have a product of two binomials that is greater than 0. So apparently this is 3x cubed plus 2 cubed, right? And the second one can be rewritten as 1 minus 2 to the 1/3, then x. So 1 cube minus this cube, right?
Mm-hmm.
Okay, so we can use this formula to factor them. There's another one, a cube, difference between two cubes equals all right, so first of all,
All right, let me get it.
Okay, so the first part can be factored to 2x plus 3x. Sorry. 3x plus 2 times 9x squared minus 6x plus 4, right?
Mm-hmm.
Okay, so we have a binomial here. We have done many times of this factor, and we know actually this part is always greater than 0, right?
Mm-hmm.
Why? Because you can write it in vertex form. Well, this is just 3x minus 1 squared. Then if you expand it, you will get 9x squared minus 6x plus 1, right? Because you have a plus 4 here, then we should add a plus 3. So as you can see here, this is some real number squared. This number here is always equal to or greater than 0, right? Then plus a 3, so this expression is always greater than 0, right? So, okay, we can just leave it there. Let's consider the next one. Next one is 1 minus minus 2x cubed equals 1 cube minus so this is our A, this is our B, right? So this equals 1 minus B times 1 squared plus AB, which is 2 to the 1/3 x, then plus B squared, which is 2 to 2/3 x squared, right? Then let's try writing this in a vertex form. So we can try use 2 to the 1/3 x, then plus, probably we should try 1/2, right? Square. And if you expand it, you will get 2. So this squared is 2 to 2/3 x squared, which is the term here, then plus 2ab, which is 2 times 1/2 is 1, then times this term, which is 2 to the 1/3 x, which is the second term, right? Then plus 1/4, because you have a 1 here. So we need to make up a 3/4. So this is actually 1 minus 2 to 1/3 x, then times a 2 2 to 1/3 plus 1/2 squared, then plus 3/4. Okay. And then the original expression is equivalent to 3 times plus 2 times 3x minus 1 squared plus 3. Then times 1 minus 2 to the 1/3 x. Let's just copy that. This is greater than 0, right? And because this factor is greater than 0, and this factor is always greater than 0, right?
Mhm.
So we can divide both sides using the product of these two terms. So this is further equivalent to 3x plus 2 times 1 minus 2 to the 1/3 x greater than 0. So we only need to solve this inequality here. And luckily, we have already know how to solve it. Actually, you can treat this as an ordinary number. So this is actually a quadratic function, right? Left side is a quadratic function. So the highest order is 2, right? 1, 2, 2 is 2. So for a quadratic function, we can first decide its opening direction. So you have a 3 here and a negative number here, right? So the leading coefficient is negative. So that means the quadratic function will open down, right? And one of the zero is zeros. One of the zero is negative 2/3, and the other one is x equals this reciprocal of this number, right? Reciprocal of this number. Understand? You can just treat it as an ordinary number. So opening down has 2 zeros. That means we can sketch this graph like this. One of the zero is here, and the other 0 is here. Opens down. So this is a sketch of the graph, right? And our task is to find any interval that makes this function greater than 0. And apparently this interval will do, and this interval will also do, right?
Isn't it the other way around?
What do you mean?
Because it's greater than 0.
Oh, sorry. My bad. Should be the interval in the middle, right?
Mm.
All right, should be here. Okay, therefore, the solution is x should be greater than negative 2/3 and less than the reciprocal of this number, right?
Mhm.
Okay, this is the final solution. All right, any questions?
Can you go back? Your next page. Okay.
Okay, then let's see the next one. Okay, solve this inequality. You have a ratio on the left side, right? Ratio of binomials and equal to or less than 0. So if you have a less than or equal to 0, usually we'll treat it as two questions, two sub questions, right? So first of all, let's mark it. Original expression is equivalent to two problems. One of them is this ratio here is equal to 0, and the other one, or left side, can also be less than 0. Okay, let's call this 1 and let's call this 2. Then we need to solve them separately. So equation 1 is equivalent to, if you have a ratio that is 0, that's equivalent to the numerator must be 0, right? And at the same time, the denominator cannot be 0. Understand? And then we can solve this system of equations. So first of all, x is -4/5, and then x cannot be -2, and x cannot be 3, right? And if you consider both of the conditions, this is equivalent to x can be 4/5, right? Okay, next, okay, let's call this 3. Next, let's solve inequality number 2. So when you have a ratio that is less than 0, it is equivalent to the product of the numerator and denominator is less than 0, right? And if you consider the function on the left, this is actually a polynomial function because it's simply a product of 3 binomials. Then let's find its degree. Highest possible order, that is called the degree. Degree is 1, 2, 3, right? And then leading coefficient is positive, positive, positive. So leading coefficient is a positive real number. Then we know this, its end behavior will look like this, right? Okay, next, let's find its zeros and orders. Okay, of course, you don't have to draw this here. You can draw it at the last step. Zeros and orders. So first of all, x can be -4/5. X can also be -2, and x can also be 3, right? Okay, then let's draw the sketch. So first of all, -2 is here. And next one is -4/5. Last one is 3. Then because the end behavior will look like looks like this, so x came all the way from -∞ to the first 0. because any of the zeros have order 1, right? So it just crosses each zero like this, because 1 is an odd number, and it cannot be any of the zeros. Therefore, our task is to find any interval that makes this function less than 0, as shown here. Therefore, the solution to the inequality number 2 is x can be less than -2, or x can also be within -4/5 and 3, right? This interval will make it less than 0, and this interval will also make it less than 0. Let's call this number 4. And actually, its final solution, we need to consider both the solutions to the equation here and solution of the inequality here. So from number 3 and number 4, we know the final solution is x can be less than 2, or x can be greater than or equal to -4/5, then less than or less than number 3. Okay, next one. So usually we should move everything to one side, right? Do not just multiply both sides using a product of the common denominator, because you don't know whether this expression is greater than or less than 0, right? So do not just multiply both sides. Instead, we can move everything to one side and rewrite the expression using the common denominator. Okay, so first of all, original expression is equivalent to, for example, we can move everything to the left. Then 6/(x−5) minus 5/(x−3), greater than or equal to 0, right? So next, we can rewrite the expression on the left side using the common denominator, which is x-5 and times x-3. Then first, we have 6 times x-3 minus 5 times x-5, which is greater than or equal to 0, right? Next, let's simplify the numerator, which is 6x minus 18 minus 5x plus 25 over x-5, x-3 greater than or equal to 0. Then this is further equivalent to 6x minus 5x is x. Then minus 18 plus 25 is plus 7. And over x-5 times x-3, right? Mm-hmm. And this actually converted to a problem that we have already know how to solve, right? This is actually the same with the problem we have met here. So you can use the same method. We can treat it as two problems. First of all, the ratio here can be 0. This is actually an equation. Or secondly, this ratio on the left can also be greater than 0, right? So let's call this 1 and 2. And the task is to find the solutions to 1 and 2 separately. And then we can consider the final solution, considering both of the cases. Okay, so the equation is equivalent to, if you have a ratio that is 0, this is equivalent to the numerator must be 0, but the denominator cannot be 0. And considering both these cases, this is equivalent to x is just -7. If x is -7, of course, x equals -7 cannot make this one 0. So x equals -7 is the solution to the equation. Let's call this number 3. Then let's consider the inequality. Again, we have a ratio that is greater than 0. And this is equivalent to the product is greater than 0. Then we can consider the function on the left. Y equals x plus 7, x minus 5, then x minus 3. Actually, this is a polynomial function. Then first, let's find its degree, which is the highest order of x, which is 3. And the leading coefficient is 1, 1, 1, which is greater than 0. And then let's find its zeros and orders. Okay, first of all, x can be -7. Next, x can also be 5, and x can also be 3. And each of the 0 has order 1. Order 1 is an odd number. So basically, we have a sketch like this. -7, 3, 5. And degree 3, leading coefficient above 0, that means this function will cross each of the 0 like this. And our task is to find any interval that makes this function greater than 0. So apparently, this interval will do, and this interval will also do. Therefore, the solution to number 2 is x between -7 and 3, or x is greater than 5. So let's call this number 4. Then our final solution came from number 3 and number 4 here. The final solution is x can be within number -7 and 3, or x can be greater than 5, and also x can be exactly -7, right? Okay, any questions?
No.
All right, so let's have a look at the next one. Okay, next one again. On the left side, we have a ratio, right? Ratio that is less than or equal to 0. Okay, so apparently this can be treated as two questions. One of them is an equation and the other one is an inequality, right? Okay, first of all, the denominator here is a trinomial. For a trinomial, first let's have a look at if we can factor it to a product of some binomials. If that can do, that will simplify this question, right? Okay, so usually in order to factor it, it's better to rearrange all the terms from the highest order to the lowest order. So this is -x² plus 5x minus 4, right? And we have a -x², so let's try using the cross multiplication. -x² can be factored to x by -x. Then -4 can be factored to -4 times 1, right? Then by cross multiplication, we'll get 4x plus x. This is 5x, which is the term exactly in the middle, right? So first factor is x minus 4. The next factor is negative x plus 1. Okay. Of course, these work should be done on a scratch paper. You don't have to write it here. You only need to write the final result of the factoring. So you can write it from here. Original expression is equivalent to, okay, first of all, 3x minus 5 to the power 4 over the factored form, right? X minus 4, then minus x plus 1, right? Okay, then this is less than or equal to 0. And this is equivalent to, again, you have something less than or equal to 0. Usually we treat it as two sub-questions. First question is, the ratio is 0. Or second question is, the ratio here can also be less than 0. We need to find all x that can satisfy either of these two expressions. So let's call this 1 and 2. Then let's consider the first equation. Number 1. Equation number 1 is equivalent to, first of all, a ratio that is 0 means the numerator must be 0 and the denominator cannot be 0, right? Do not forget the constraints. The denominator cannot be 0, otherwise it will enlarge the solution set. Okay, so this is equivalent to, first of all, x can be 5 over 3. That'll make the numerator be 0. X cannot be either 4 or 1, right? Therefore, the solution to the equation is x equals 5 over 3. Why? Because when x is 5 over 3, of course, x cannot be 4 or 5 or 1. Okay, so this is a solution to the equation. Next, we want to solve the inequality here. Let's copy that inequality to the second page here. Okay, so number 2, the inequality is equivalent to, so this time you have a strictly less than 0, right? If you have some ratio that is strictly less than or greater than 0, this is equivalent to the product of the denominator and numerator must be less than 0, right? Mm-hmm. Okay, if you consider the function on the left, this is again a polynomial function. Let's consider this function on the left. And first of all, we find its degree, which is the highest order of x. So we have 4, 5, 6. Degree is 6, and leading coefficient is 3 to the power 4 times 1 times -1. Of course, this is less than 0, right? Mm-hmm. Then the end behavior will look like this. Degree is even and leading coefficient is negative, so end behavior look like this. Next, we should consider the behavior in the middle. This depends on the zeros and their orders. So let's analyze the zeros and their orders. Okay, first of all, x can be 5 over 3 with order 4, because the power of 4 here you can find. And next 0 is x equals 4 with order 1. And next x can be 1 with order 1, right? Then we can sketch its graph. First of all, x can be 1. Then 5 over 3, the largest 0 is 4. Okay, as x came from -infinity to the first 0, it will look like this. Then at the first zero, x equals 1 because it has order 1, so it will cross this point. Then to the next zero. Next zero has order 4, so it will bounce back. The next zero, 4, has order 1. 1 is odd, so it will cross this point. And then let's find all the intervals that can make this function less than 0. Okay, first of all, any of the zeros cannot be reached. Okay, any interval that makes this function less than 0 is x is either less than 1 or greater than 4, right? Therefore, the solution to inequality number 2 is x less than 1 or x greater than 4. Okay, so let's call this number 3 here. Solution to number 2 is 4. Therefore, according to 3 and 4, we have the final solution. Final solution is, okay, x can be less than 1 or x can be greater than 4 or x can be exactly 5/3, right? Okay, next one. All right, again, we have a ratio that is less than or equal to 0. And we need to make this to 2 sub-questions, right? Can just use similar method. So original expression is equivalent to, first of all, the ratio on the left can be exactly 0, or ratio on the left also be less than 0. And let's call this number 1 and number 2. Then we need to separately solve them. So equation number 1 is equivalent to, first of all, the numerator can be 0, right? But the denominator cannot be 0. And then let's solve it. This is equivalent to, okay, from the first equation, we get x can be either -5/2 or x can be 2/3, right? And from the second, we can solve x cannot be 3. And of course, this is equivalent to x can either be -5/2 or x can be 2/3. Then let's call this number 3. So this is the solution to the first branch. You follow me?
Yeah.
Okay, so for the second branch, this is apparently an inequality. And the left side is a ratio. The ratio that is less than 0 is equivalent to the product of these terms, of these factors, is less than 0, right? And then we consider the left side. This is actually, again, a product of 3 binomials. Again, this is a polynomial function. So let's consider the function on the left. Y equals 2x plus 5, 2 minus 3x, then 3 minus x. First, we can find its degree, which is the highest possible order of x. So 1, 2, 3, degree is 3. Leading coefficient is 2 times -3 times -1, which you will have a positive number. So degree is positive, leading coefficient is also positive. Then you will have an end behavior like this, right? And the behavior in the middle depends on the zeros and their orders. So let's find their zeros and orders. Okay, first of all, x can be -5/2 with order 1. Then x can be 2/3 with order 1, and x can be 3 with order 1. Then we know its sketch. Sketch will look like this. Smallest is -5/2, then followed by 2/3, followed by 3. Then its sketch will look like this. Our task is to find any interval that makes this function less than 0, right? You can see less than 0 here. So first of all, x can be smaller than -5/2. Next, x can be within 3/2 and 2/3 and 3. All right, so you need some time?
No, it's okay.
All right, so for the second inequality, we know that x can be less than -5/2, or x is within 2/3 and 3, right? So let's mark it as number 4. Number 4 is the solution to number 2. Therefore, according to number 3 and number 4, the final solution is the unit of the two solutions. Is x can either less than 5/2, and x can also equal to this number, or x can be greater than or equal to 2/3 and less than 3. And this is our final solution.
Okay.
All right, any questions?
No.
Okay, let's see the next one then. Solve the inequality here. Okay, again, do not just multiply both sides using the product of these two factors, because you don't know whether it's greater than or less than 0, right? Instead, we can just move everything to one side and rewrite that using a common denominator. Okay, so let's, for example, let's move everything to the left. Then the original expression is equivalent to 1/x - 1, then followed by 3 - 3/x + 2. Then +2. Less than 0, right? And this is for the equivalent. Okay, so what is a common denominator on the left? It's just the product of x - 1 and x + 2, right? And if you rewrite using common denominator first, you will have x + 2 there, -3 times x - 1, then +2, x - 1, x + 2, right? And if you're not so sure about the result here, you can just assign this into each of the terms. Okay, for example, if you verify a result, x + 2 over this one is x - 1, the reciprocal of x - 1, right? And second term is here, -3 times x - 1 divided by this is -3, right? Sorry, -3 over x + 2. So next, you will get 2 times x - 1 times x + 2. Over this, you'll get +2, right? This is exactly with to this expression. So that means the first step is correct. All right, then let's simplify the numerator here. Then this is equivalent to x plus 2 negative 3x plus 3, right? Then plus 2 times x squared minus x plus 2x is plus x. Then minus 2, right? Okay, then it's over x minus 1, x plus 2. And this is further equivalent to x plus 2 minus, okay, let's simplify the first part. 5 minus 2x plus 2x squared plus 2x minus 4, right? X minus 1, x plus 2. Then, sorry, I should use a inequality. I should use equivalent symbol here. This expression is less than 0. This is equivalent to, okay, this term cancels with this one. So 2x squared plus 1, right? Over x minus 1, x plus 2, less than 0. So can we simplify this further? So note here, this number is greater than or less than, greater than or equal to 0, right? Do you understand?
Mm-hmm.
And plus 1, so this whole number here must be greater than 0, right?
Mm-hmm.
So that means we now can divide both sides using 2x squared plus 1, because this number is always greater than 0. So if we divide both sides, we don't change the symbol here, right? So this is equivalent to 1 over x minus 1, x plus 2, less than 0, right? And again, because the numerator is positive, then the ratio is less than 0. That means the denominator must be greater than or equal to, or greater than or less than 0. Positive over what kind of number?
Negative.
Okay, it's negative, right? So basically, as you can see here, the complex rational problem is converted to a very simple inequality here, right? And our task is to find any interval that makes this inequality holds. So left side is actually a quadratic function. Leading coefficient is 1 by 1, so it's positive, right? Leading coefficient is positive means this quadratic function is opening up. And it has 2 zeros. One of the 0 is -2 here. The other 0 is 1, right? So in order to find the degree, leading coefficient, and zeros, if you have a quadratic function, the problem becomes much easier because we already know and this function is whether opening up or down. And apparently, if the leading coefficient is positive, we know it's opening up. And we also know the 2 zeros here, right? One of them is -1, and the other one is 1. And the task is to find any interval that makes this function less than 0. So we can't reach the zeros. But this interval here will make this function less than 0, right? Okay, therefore the final solution is x is between -2 and 1. Any questions?
No.
Okay, let's see the next one. Again, the method is similar, right? You can't just multiply both sides, but instead we need to move everything to one side. So the original expression here is equivalent to, okay, move everything to the left. Greater than or equal to 0, right? And this is equivalent to, okay, so how about I leave this to your home, a new assignment, okay? And let's talk about this next time because we're running out of time. Because the method is similar, right? You have already know this. And how about this one? How do you solve this? Can you multiply both sides using this?
Yeah. Yeah.
Why?
Because there's 2.
But is it positive or negative? Do you know that?
No.
So if you don't, you can't decide the direction, right?
Yeah.
So that means you cannot just directly multiply both sides because if you don't know whether it's positive or negative, you don't know if you need to change the symbol here. So that means, again, we need to move everything to the left or right.
Okay.
So,
and then it's the same denominator.
Yes, move everything to one side and rewrite that using the common denominator. Okay. For example, if you move this one to the left side, then you will get -2 over x minus 4 times x plus 5, right? So what's the next step?
It's just on the same fraction.
Yes, you should try to simplify this, right? So you need to rewrite this again using common denominator, which is x minus 2. Then simplify the left side.
Okay.
And eventually you will get something, you'll get some ratio that is less than or equal to 0. Again, this can be considered as 2, right? 2 problems.
Okay.
Okay, can use a similar method. All right, next one, again, same logic, right? So I'll leave this to your next assignment, right?
Okay.
Okay. Let me mark it. Number 9 I'll give you the solution next time. Number 8 and number 7. Okay, number 10.
Can you copy and paste it into the new PDF too?
Okay, no problem. You can download it later. Okay.
Okay.
I'll let you know if I finish that. It's not finished yet. Number 10. Okay, if x is real and this is an equation, right? Then what is a complete set of values of x for which y is real? Actually, you can consider it as an equation in terms of y. So what does it mean in terms of y? Everything except y is constant. You can treat it like that. If you treat anything except y as constant, this is a quadratic equation, right? So for any quadratic equation, for example, any quadratic equation, let's say in terms of y. So under what conditions the solutions has this equation has real solution?
B squared minus 4ac.
You need to consider the determinant, right?
Yeah.
Okay, so back to this question, what is the determinant here? What is delta?
4x squared plus
or negative?
Oh, negative 4 times 4 and 6.
This is a constant,
X
right?
plus 6.
Yeah, anything except that y is constant. This is a constant, right?
X plus 6.
So the delta needs to be
greater than 0.
Greater than, how about equal to?
Yeah.
Equal to will also do, right? Equal to will have a double root. That root is also real, right? Do you know why? Because the roots are given by this formula, right? So as if delta is 0 or anything that is greater than 0, you will have real roots. Otherwise, you will have a negative number under a square root sign that will give you complex and imaginary roots, right? Okay, so as long as this number is greater than or equal to 0, you will get real roots. So this is actually a inequality in terms of x. So that means it's possible to solve this. This is just 16x squared minus 16 Oh, sorry, I should use equivalent sign here. This is equivalent to 16x squared minus 16 times x plus 6 greater than or equal to 0, right? And this is equivalent to 16x squared minus, oh, before we explain that, actually we can divide both sides using 16, right? 16 is a positive number, so we know we don't change the equality symbol here. So this is equivalent to x minus x plus 6 greater than or equal to 0. And further, this is x minus x squared minus x minus 6 greater than or equal to 0, right? So it's better to factor it to see it zeros. So actually it's not very hard, right? So x squared can be factored to x by x. Negative 6 can be factored to negative 3 by 2. And by cross multiplication, you will get negative 3x plus 2x, which is negative x here, right? So this is your first factor. This is your second factor. So this is equivalent to x minus 3 times x plus 2 greater than or equal to 0, right? And you can see the left side is a quadratic function, right? Is opening down or up?
Up.
Okay, opening up. 2 zeros, right?
Yeah.
One of them is negative 2. The other one is 3. And our task is to find any interval that makes this function greater than or equal to 0, right? So this point will do, this point will do, and this interval will also do, this interval will also do, right? Therefore, the solution is x is either less than or equal to negative 2, or x is less than, greater than or equal to 3, right? So that means as x yields to this intervals, then y is a real number in this equation. Okay, any questions?
No.
Okay, then let's see question 11. Okay, it asks you to prove that for any x that is less than 0 and x is a real number, this inequality is true. Okay, so you can prove this in either direction. You can prove it backwards. So in order to prove this one is true, as long as we can prove, for example, we can multiply both sides using x, right? Because we know x is less than 0. If we multiply both sides using x, we should change the equality symbol, right? So if you want to prove this, as long as you can prove this, sorry, I need to change symbol here. As long as you can prove this one is true, then this one is true, right? Why? Because if this one is true, you can then divide both sides using x, right? Divide both sides using x. X is positive number. If we divide both sides using x, then we'll get this one. You need to change the inequality symbol, right? If this one is correct, this one is also correct, right? So that means we should use an arrow pointing to the left. And then we need to prove this one is true, right? For any x that's less than 0. In order to prove this one is true, actually, as long as you can prove this one is true, you will do, right? And in order to prove this one is true, actually, you need to prove this inequality is always true, right? And is it always true?
Yeah.
Because x is real number, +1 is also real number. Real number squared is always greater than or equal to 0, right? So what can we see here? Because inequality number 1 is always true for x belongs to real number, right? Therefore, let's say asterisk is always true for x belongs to real number and x is less than 0, right? Okay, and also you can write it in a forward way. So according to our analysis, as long as this one is always true, right? So what can we see here? So let's go, this is method 1 and method 2. You can write from the very beginning here. Okay, have a look at this. You can say for any x belongs to real number, we have x plus 1 squared greater than or equal to 0, right? Which means x squared plus 2x plus 1 greater than or equal to 0, right? Which can indicate x squared plus 1 greater than or equal to negative 2x, right? And because x is less than 0, then if we divide both sides using x, we can get x plus 1 over x. You need to change the direction, right? Negative 2. So this one is always correct for x belongs to any real number and x is less than 0, right? In this way, we also can prove this is true. Okay, any questions?
No.
All right, let's see the next one. Okay, show that the square root of the sum of 2 squares over 2 is always greater than or equal to the, so what does this call? This is called arithmetic mean, right? For all non-negative real numbers x and y. Again, you can analyze this you can approach this problem backwards or forward. So in order to prove this one is true, we need to prove that x squared plus y squared over 2 greater than or equal to x plus y over 2 squared, right? Because both sides is a positive number. If we can prove this, the square root of, if the left side is greater than the right side, then we can find the square root, right? Square root of the left side should also greater than the square root of the right side. Okay, and in order to prove this one is always true, we need to prove that x squared over y squared plus y squared over 2 greater than or equal to x squared plus 2xy plus y squared over 4, right? And in order to prove this one is true, we need to prove that 2 times x squared plus y squared greater than or equal to x squared plus 2xy plus y squared. Then in order to prove this one is true.
Over 2.
What do you mean?
Why isn't it over 2 on this side?
Oh, because I divide both sides, multiply both sides using a 4. Why? Because as long as you can prove this one is true, then you can divide both sides using a 4, right? Then you will get this one is true. If you get this one is true, this one is true, this one is true, this one is true, right? So that means in order to prove this one is true, actually, we only need to prove this one is true, right? And in order to prove this one is true, actually, you need to prove x squared plus y squared minus 2xy greater than or equal to 0, right? So is this one always true? If you can't see it clearly, you can just rewrite it as x minus y squared greater than or equal to 0, right? Because this one is always true, right? Therefore, this one is true. This one is true, this one is true. This one is true, this one is true. So it's like a chain reaction, right? As long as you can prove this one is always true, then follow the chains. The original expression is always true, right? So we can say, let's label it number 1, because number 1 is always true. Therefore, the original expression is always true, right? Of course, this is method 1. Method 2 is to think it in a forward way. So this is our analysis, right? In method 2, you can write it in a forward way. For example, if you can say, because, you can write from the very beginning here, because x minus y squared greater than or equal to 0, right? This is always true, right? Therefore, x squared minus 2xy plus y squared greater than or equal to 0, right?
Wait, but like, how do you get this from this? Like, if you're only going to use method 2?
Because according to our analysis you need to do some brief analysis. So you need to analyze such
so
as.
you have to do this before you do that.
Yes, you have to do this. But in your writing, your reasoning, or in your solution, you can write either this way or this way.
Oh, so you still have to do this.
Yes, you still have to briefly analyze this question.
Okay.
In order to prove this, what we need to prove. And then in order to prove this, what we need to prove. This helps you to analyze this problem.
Okay.
And in your writing to your readers, you can either write this way or this way.
Okay.
Okay. And if you write in a forward way, you can write like this. Because x minus y squared is greater than or equal to 0. Therefore, if you expand it, you will get x squared or minus 2xy plus y squared greater than or equal to 0, right? And then 2x plus 2y squared left side is x squared minus 2xy plus y squared this is actually the left side, right? Greater than or equal to 0. Therefore, basically follows the reverse order of this. So 2x squared plus y squared greater than or equal to, not 0 here. This should be x plus y squared, right? And this will give you x squared plus y squared. Let's say, if I divide both sides using 4, and this will give you, because both of the two sides are non-negative, right? So then you can find the square root. Square root of the left side is greater than the square root of the right side. Square root of the right side is x plus y over 2, because x plus y over 2 is positive. So you can just remove the absolute symbol, right? You can choose either way. Any questions?
No.
No, okay, let's see the last question. All right, so prove that if x, y, and z are real numbers, we have this inequality, which is always true. So any thoughts about this? That involves x squared, y squared, and xy. Reminds you something?
Yeah.
Probably we can try using this one, right? X difference between x and y is x squared minus 2xy plus y squared, right? And we have also y squared and d squared. So probably we will also use y minus z equals y squared minus 2yz plus z squared, right? And for x and z, we can try using x minus z squared. This equals x squared minus 2xz plus z squared, right? Okay, so note here something, x minus y is a real number, right? Real number squared is always greater than or equal to 0, right? This one is also greater than or equal to 0. This one is also greater than or equal to 0, right? So how about we just add 1, 2, and 3. Left side, at left side, always equal to or greater than the right side, right? Because all any of the 3 inequalities, left side is always larger. So left side, sum of the left side should be greater than or equal to the sum of the right side. Right side is just 0, right?
Why did you put square outside the bracket?
Okay. Right? You follow me?
Yeah.
Okay, so then we can try to simplify the left side. This will give you 2x squared, right? And 2y squared. Then 2v squared, right? Then minus 2xy minus 2yz minus 2xz greater than or equal to 0, right? Now can you see this is always correct?
Yeah, divide by 2.
Divide by 2, then we'll get x squared plus y squared plus z squared minus xy minus yz minus xz greater than or equal to 0, right? And we can move these 3 terms to the right. Therefore, for x squared plus y squared plus z squared, always greater than or equal to xy plus yz plus xz, right? So basically the key is to try to think about what does this actually tells you. When you see x squared and y squared and xz, you should try using this, right? Because it has x squared, y squared, and xy here. Okay. All right, I'll give you some more similar questions to practice. I'll let you know when it's available. Okay.
Thank you.
No problem. I'll also upload this to Google Classroom for you to refer to.